All right, good afternoon everyone. This time we're now gonna work on volumes and surface area with our goal to solve application problems on volumes and surface areas. Okay, so we have in here different geometric figures like this. What is this again? Anyone? A cone. Thank you. Right. So a cone has two parts. That is the what? The base. In this case, is a circular base, and certainly this is the lateral surface area as well. Okay. Now, what we know about this cone is that it is related to what we call a cylinder. Okay, so how related are they? Well, typically for a cylinder like this, it has two circular bases, right? The one on top and the one at the bottom. And it has also this surface in here. This is called the circumferential surface. Why is it called the circumferential surface? Simply because if you cut it along this height, okay, if you cut it along this height, and you remove that one, that will cover the entire circumference of that part. That will be a rectangle with what? Height as its width, and the circumference 2 pi r as its length. Okay, and again, two squares as well. Okay, so how related are these two? Anyone? Well, as you may notice from the formula, for a cylinder, the formula is what? Pi r squared h, right? So that means the pi r squared will correspond to that circular base on top or even at the bottom, multiplied by the height. Okay, and typically in here, the height is what? Perpendicular to your circular surface on top or below, right? Now, however, for the cone, the formula is what? 1/3, okay, of its cylinder counterpart. So in short, if you have a cylinder and a cone with the same height and the same circular base, then the cone will be what? 1/3 of the volume of that cylinder, right? So let's see that one in here, if that will be possible, okay? So we have in here the entire volume of this cylinder. So what we're gonna do is what? Well, I'm gonna fill this cylinder, this cone now with. Can I fill this up? Okay, that'll be interesting. So if I fill this up like this, I should have a funnel, by the way, right?
You can make one out of paper.
A what? Oh yes, yep. Can anyone do me a favor and make a funnel out of this? All right. So good. Oh, here it is. Funnel. Yeah. Good. Yeah, I'm trying to pour it in, but since the spout in here is too small, it's kind of like making a challenge as well to do that one. So here it is.
You want somebody to hold it?
Oh, I think this will be good, right? What is this? Oops. Okay. Can someone help me out? Victoria, thank you. It looks like this is a two-man job, right? What do you think? Two people job, right? Thank you, Victoria. Here it is. And let's see. So if I pour this in here. Okay.
Oh, it's coming out the side. Hang on.
It's like a little bit messy. There we go. Oops. Got it. Okay. Oh, I also have one thing to do. If I have a beaker here and I pour it in here, that might be easier, right? What do you think? Hopefully. It's good. Oh, yeah. Okay. Thank you, Victoria. That works, right? Here's your deal. You can pour it to the beaker first. Anyone who've had chemistry already? Right? Beaker? Oh, forensic. You're gonna do some science investigation or experiment-ish. So yeah. You're gonna use beakers, graduated cylinders. Yeah. By the way, a beaker is the shape of what? What is this shape? Cylinder. Very good. Oops. Okay, so in an ideal world, right? Yeah. Let's go to the ideal world scenario. What we call, utopia, right? Is it a perfect world? Yeah. In a perfect world, this will be the case, right? Oh, look at that, right? So in a perfect world, if this cone will be filled out with this, then what can you say about the remaining beans on this cylinder? How much beans is remaining in here? What portion of the whole cylinder beans will be? How much?
75%.
Well, look at this one. This is, if I pour in a third of these in here, again, in a utopian world, right? Then that means how much will be left in here? 66.6%, right? Or what we call 2/3. Very good, right? In short, if we pour in 3 of these cones in here, this would fill this up. Are we good, guys? All right. So that's our cylinder and cone scenario for such. The next thing that we're gonna do is this. And what is that? Here it is. Okay, anyone who knows what this one is?
A pyramid.
A pyramid, okay. Well, this one, typically it looks like cone because the cone has also the triangular shape, but this one has a what? Square base. So this is technically called a square pyramid, okay? It's a pyramid, but the base is that of a square. Very good, right? Now what we're gonna do is to solve for the volume of this pyramid, okay? So how to solve for the volume of that? Well, first thing that we're gonna do is to measure the side lengths of these one first, okay? Where's our ruler last time, guys, right? Can anyone see a ruler in there at the back? I thought we have some rulers in here last time. I think I got all of those rulers last time, right? Okay. So, how to get the area of this square pyramid in here? So as you may notice, the formula is as follows. The volume of any pyramid is equal to what? 1/3 again times the what? BA. The BA in there is what we call the base area. What is the area of this base? Okay. That's a square. So that's what? Side times side. And you get the what? Not this slant height. Okay. We want the what? The vertical height instead. Okay. We good with that one? So once again, you get the side length of each. You multiply these two together. And then multiply that by, not the slant height, okay? Not this, those are slant heights, but the height from the center of this base, square base, until the tip, or what we call the apex of this square pyramid.
Area is length times width times height, right?
The area, well, that's the volume, right? When you say length times width times height, that's the volume, however, of what we call a prism. So if you see this prism in here, okay, as such, then yes, that will be the volume for this will be what? Length times width, very good, times height. And how do you know which one is length, width, and height in a what we call rectangular prism? Well, typically the length is always the longest side. Good. The length is always the longest side. The height is always the what? The vertical component, okay? And the width will typically be shorter than the length. Okay, so again, on a prism, how do you know the difference between the length, the width, and the height? Well, length signifies the longest. Height signifies the tallest, right? The perpendicular, okay, the vertical. And the width is what? Always,
How big it is?
and always typically shorter than the length, okay? So that's a volume for a prism. But however, in here, so for example, in this case, to get the surface area of this prism, what do we do for such? Let's do this. Okay, so to get the surface area of this prism, what we're gonna do with the length, width, and height are as follows. So the surface area is counting like how many surfaces are here. How many are in here, guys, for this particular rectangular prism? How many surfaces are there all in all? 6. Very good. Okay, let me just give you an example of a rectangular prism for such. Okay, so this one can be considered, okay, so here it is. Okay, I saw something in here. Okay, rectangular prism. Okay, good. So in this rectangular prism, that will be the length, longest. That will be the height because it's vertical. Okay, and where is the width? That is the width. Okay, now how many surfaces are there? 6. Very good. The top and the bottom surface. Okay, the front and the back surface. Okay, and the left and the right surface, well, depending on where what your perspective is. So for me, this is the left and that is the right. But for you, that's the other way around. But again, 6 surfaces total, right? Top, bottom, front, back, left, and right surfaces, okay? And each surface in here are different shapes. As you may notice in here, the front and the back, the top and the bottom are what? That is the length and that is the width. Okay, 2 length times widths. Okay, the front and the back are what? That is the length and that is the height. Okay, so 2 length heights as well. Okay, the left and the right are the same. That is what? That is the height, that is the width. So that's height width, 2 height widths. Okay, so total of 6. 2 for top bottom, 2 for front back, and 2 for right left. Okay, so with that being said, the formula are as follows for that. Oops. The surface area, again, not the volume, but the surface area of this one should be the following. Okay, here it is. 2 of the length and the width. So where's that length? Length and the width. Okay, length and the width. Okay, so that's the what? That's the bottom and the top. Okay, so this is for the top and bottom. Next, what is this? 2 times the width and height. Where's the width? This is the width and that is the height. So that's 2 times 3. That is the what? The front and the back. Okay, so we got the top, bottom, we got the front and back. The height and the length are where? So this is the length, that is the height, that is the what? Right and left surfaces, okay? And 2 HLs as well. So if you total all of them, guys, plug in your calculator, what you're gonna get? So again, you can use your calculator or you can do this manually as well, okay? So how much is that gonna be? What's 5 times 2?
10.
10, very good. 2 times 3? 6. 3 times 5? 15. All right, so adding them all up, how much is that? 10 plus 6 plus 15.
10 plus 6.
Well, 10 plus 15 is already 25,
25.
right?
So 31.
Plus 6, 31. Times what? Double each of them, right? So how much total?
70.
It was 31.
31 times 2, right?
Oh, 62.
What's the unit for that, by the way?
Meter. 62.
62 is a value. What's the unit?
Meter.
Square units, right? And what is this unit in here? Meters, right? Why square meters? Because it's surface area, right? When you say area, the units will always be what? Square units. In this case, square meters, okay? In English, units can be square inches or square feet, square miles, okay? Good. For the volume, what do we do? Well, again, basically just multiply length with height, okay? The longest, the vertical, and the width, okay? And after that, you're gonna get how much in terms of units? 3 times 5 times 2, how much is that, guys?
30.
30. And the unit for volume is what? Cubic units, okay? So as you may know, oops. Okay. So as you may notice in here, that will be the cubic units for that, okay? Again, for a, what we call, this is a cube already. For a cube, however, it's different simply because everything are equilateral. Anyone who can tell us what we mean by equilateral? The side lengths are all the same. So that means the length, the width, and the height are all the same. Let's just call them S or side length. So basically, the formula for that will be what? Length times width times height are all S. That's S times S times S. S cubed. Okay? But for the surface area, that will just be what? 6S squared. Why 6S squared? Because each surface is a square, S squared, and there are 6 surfaces altogether. So that's 6S squared for that. Okay? Questions for that one, guys? The last major geometric figure that I'm gonna mention in here is what we call the, okay, what do you call that? A sphere. Very good, right? A 3-dimensional ball, that is a sphere. Our Earth is almost a shape of a sphere, but typically it's called what?
A globe. Ellipse.
Okay, if you search it on AI, the shape of the Earth is in fact almost a sphere. It's called an oblate spheroid, right? What's an oblate spheroid? That means a little bit of like bulging on the equator, okay?
It's almost like an oval.
Very good. And a little bit of flat on the poles. Why is it the case? Because of the rotation, right? I mean, the Earth just keeps on rotating on its axis around the sun for what? Millions of years? Well, just imagine something that's been like spinning its entire time. So it's going to be bulging, right, on the equator and a little bit flat on the poles,
It's
right?
like a top that doesn't stop spinning.
That's right. Yeah.
If it did, we die.
Oh yeah, that's right too. Anyway, assuming it's a perfect sphere, then the formula for the volume are as follows. Okay, I have mentioned that one in here. Here it is. Yeah, it should be somewhere. Okay, so it's in here. So volume of a sphere is equal to, this should be in there, guys. Okay, why is this one? Okay, this one should be moved in there. Okay. 4/3. Oops. Okay, let me just do this one. The volume of sphere. I think this was moved, right? Was this moved?
I think it's because you zoomed in, maybe.
Yeah, because you got it. That makes sense to me.
Did I zoom it in? Okay, there we go. Yeah. Sorry. For a sphere, the volume is what? 4/3 pi r cubed. Okay, again, the volume of a sphere is 4/3 pi r cubed. R is basically the radius, okay? And for the surface area, this is it. I'm gonna put this one in here. Okay. So think of a sphere's surface as what? 4 circles of the same radius rolled into one. Okay, so that's the surface area of our sphere. Okay, so there it is. Those are our necessary formulas for that. Once again, for the surface area of a cylinder, the 2 pi r squared in there corresponds to what? The top circle, a pi r squared, and the bottom circle, another pi r squared. So if a pi r squared circle on top, like this, okay, so if you look at this one, guys, that is a circle, pi r squared area, okay? That's another circle at the bottom, pi r squared area. So those are 2 pi r squareds already, okay? Now this is the circumferential surface. Once again, if you cut it in here on this end along the height, this is the circumference, 2 pi r, and that is the height. That's why that's 2 pi r times h, okay? That is the circumferential surface of this, okay? So that will be that added together. That is the surface area of any cylinder, okay? And check it out in here how it was solved for such as well, okay? So again, if you have questions, let me know about the volumes. But please do be familiar with the formulas, and hopefully you can see right now, you have seen right now how 3 of these, where are the cones? 3 of those cones of the same height and circle base can fill what? 1 cylinder. Okay. Any questions? Thank you all so much. And if you have questions, let me know.